Hashing is the process of taking a string of data and applying a mathematical function to it to produce a unique string of output, known as a hash. Hashing is often used for encryption, but that's not its only use. For example, it can be used for creating unique identifiers or quickly determining if a large amount of data has changed. But what we're interested in is using it for password hashing, applying an algorithm to a password to generate an encrypted string. And you can't reverse engineer it to discover the original password, even if you have lots of computing power. The output hash will also be unique so that it can only be recreated by using the same password with the same hashing algorithm. In short, the only way to have a password match will be to know the original password, and that's exactly what we want. The most important rule about passwords is never store passwords in the database as plain text. Always encrypt them. If they're in plain text, then anyone who gains access to your database is going to have access to every user's password. And it's not just hackers on the outside that you have to be concerned about. Authorized users are a concern too. Any site administrator, an employee, or anyone with database access has the potential to know all the user's passwords. A database backup that your ISP makes for you, or a hard drive that doesn't get wiped completely before it's sold or discarded, those have the potential for leaking passwords. And it's not just your site security that's at risk. Many users use the same username and passwords on multiple sites. So if a user uses the same password on your site as for their bank account, well then suddenly you're the security hole in the bank's site security. So please, if nothing else, do it for all of us other site developers who want to keep our sites secure. Now not only are we going to be encrypting passwords, but we'll be using a one-way encryption algorithm. So it won't be possible for anyone to get the original password from our encrypted string, including us. It works because of the principle that the same inputs to the hashing algorithm will always result in the same output. So we'll take the password, encrypt it, and store the result. When a user tries to log in, we'll take their attempted password, pass it to the same hashing algorithm, and see if the output matches what we have stored. If the output's the same, then we know the input must have been correct. If the output is different, then we know it wasn't. Now there are dozens of hashing algorithms, all with different uses, and not all of them are suitable for password hashing. MD5, SHA-1, and SHA-2 are all part of the Ruby standard library. So if you have Ruby installed, you should have these installed as well. Whirlpool and Blowfish are two other popular and well-respected choices, but they require a little more installation and configuration to set them up. So we'll stick with the first three. So which one do we choose? Well, there's a small security flaw that's been discovered in MD5. The weakness is not very simple to exploit, and probably in 99.9% of the cases, using MD5 for encrypting passwords would still be fine. But it's enough to make it less than ideal, especially since we still have two other choices. Now, SHA-1 is a good choice. Security researchers have come up with a theory about a possible weakness for it, but no one has actually discovered the weakness itself or found a way to exploit it. It's still just a theory, so it remains secure enough for most purposes. The final choice, SHA-2, is a stronger version of SHA-1, and it does not have any known weaknesses or any possible theoretical weaknesses. Now, because of the possible weakness in SHA-1, the US government is moving to SHA-2 exclusively. So if you're doing work for a government or a bank, then you should choose it, and you should also probably learn a lot more about security than I'm going to teach you here. But for most general purpose uses, SHA-1 will do the job just fine, and it's going to be a tiny bit easier to use, so it's the one we'll be using here. As I said, SHA-1 is built into Ruby, so let's try it in IRB and see how it works before we add it to our model. So instead of going into my Rails console, I'm actually just going to go into IRB. So that's not Rails, that's just Ruby, interactive Ruby. And in there, I'm going to type require and then digest/SHA-1. No hyphen or anything like that, just SHA-1 all together. What that's going to do is make sure that the digest is loaded up and available to me. That's all it did. It just made sure that we have it available. And then I'll set variable password equal to secret. That'll just be what I'm going to set as my password. Now to encrypt that with SHA-1, we call it by digest : SHA-1 dot hex digest and then whatever we want to encrypt. So it's just going to be the password that we want to encrypt. So there it is. That's the string that we get. Anytime someone inputs secret again, secret, we'll get that exact same result back out. So that's what we're going to be storing in the database, is this hashed password. That's all there's to it. Let's go to our admin user model and actually add a method for it. So I'll go into my simple CMS, into the models, into admin user. We want to do the exact same steps that we just did there. We want to do a require at the beginning, make sure that it's available to us, SHA-1, and then we'll jump down here and we'll write a new method, def, and we'll call this method hash. It's going to be a class method. We want to be able to call it anytime, not just when we have an instance. So self.hash, and then the password is what we'll pass in, It'll default to just an empty string. And then what are we going to put in there? Well, digest, sha1 dot hex digest, and then whatever was passed in. That's all there is to it. Now we have this hash method inside the admin user model so that now admin user knows how to perform hashing. Let's switch to the console and try it out. So I'll exit out of IRB. Notice that I'm in the root of my application already. So I'll type Rails console now. And I have a user already in here. If you don't, you'll want to create one. Admin user dot find one, and that should be me that I created earlier. So now let's try it. User dot hashed password. I'm going to set this hash password equal to, let's ask the admin user to hash and whatever we want the password to be. So I'll say secret. So it'll take it, it'll hash it, and it'll then add it to the instances attribute hashed password. There it is, exact same value we got back. Let's say user.save. Oh, false. I got some errors. Let's see, user.errors. The email can't be blank and is invalid. Since I've added the validations, I need to now add an email. So we'll set email equal to kevin@nowhere.com. And now we should be able to say user save, and it's true. Let's check what hashed password is, hashed password, and there's our value. And with just these couple of very simple steps, we've already greatly improved our website security. It's much better than storing passwords in the database as plain text. But as we'll see in the next movie, there are ways that we can improve it even further.